So, I'm not your doctor, but it's about time we've talked about Uranus. Yup, I started with one of those Uranus jokes. But anyway, hello wonderful person, this is Anton. Today we're going to be discussing some of the recent updates and some of the most recent observations in regards to one of the most mysterious planets in the solar system, Uranus, or as a lot of scientists usually call it, Uranus. And that's because in just the last few months, we had some new observations from the James Webb Space Telescope and a few more discoveries about two of its unusual moons. And so in this video, we're going to discuss some of these somewhat unusual discoveries and talk about what we know about this planet so far. A planet that for a very long time was actually sometimes considered to be kind of boring, or at least kind of neglected. It's one of the least studied planets in the entire solar system. But back in 1986, the Voyager 2 was able to fly by this planet and take a few beautiful shots. And unfortunately since then, there have been no additional probes to Uranus. And instead, all of the recent observations relied on telescopes like the Hubble and the James Webb. But as I mentioned in the last few months, a series of major studies, and some using some of this recent data, reanalyzed and re-evaluated some of these older discoveries, allowing scientists to completely change our understanding of what these ice giants seem to be like, and specifically in regards to their activity. And one of the first studies I wanted to discuss is this. The study that tackles an unusual mystery observed by the Voyager probe back in 1986. Something that actually bothered scientists for over 40 years now. And in this case, it was the observations of intense radiation belts involving layers of trapped electrons that seemed to be much stronger than anything we expected for a planet of this size. Or basically here, for some reason, the magnetic field seemed to be just a little bit too powerful. And so for many decades, this was thought to be some kind of an anomaly and something that might have been the result of some kind of a major collision on Uranus billions of years ago. But this recent study from December of 2025 suggests that, well, it might have been completely by accident. Voyager 2 simply caught Uranus at a very bad time. And so here, by comparing data from Uranus to the data we saw on Earth, researchers realized that there was actually a major solar storm, and specifically a solar windstorm that passed through Uranus' system exactly at the same time as the Voyager 2. And it was the storm that compressed the magnetosphere, generating high-frequency waves and accelerating electrons to near the speed of light. Or essentially, the observations were just the result of this solar storm interacting with Uranus's natural magnetic field. And this by itself is quite important because it means that the normal state of Uranus might be much calmer to what scientists saw back in 1986. And so this explains why the planet seemed to have a weaker ion radiation belt, but a very intense electron belt. So this was just a special event and not something that's permanent. But when it comes to additional observations, one of the most exciting ones was only from just a few days ago. And here, as you can see, it's actually a video, or technically a time-lapse. And that's because now we have the most detailed map ever of the planet's upper atmosphere that was recently produced by the team using the James Webb Space Telescope. And so here, the team whose study you can find in the description observed Uranus for nearly 17 hours in total, and they were essentially observing molecules of hydrogen-3. Molecules that usually act as a kind of a thermometer for the upper atmosphere of various planets. And this observation, for the first time ever, allowed scientists to create a vertical structure of the ionosphere, revealing the overall temperature changes depending on the altitude. And turns out that a lot of this seems to peak between 3,000 and 4,000 kilometers above the cloud tops. And so basically here scientists discovered that overall, the temperatures don't just kind of get colder as you go higher, but they do change in a slightly different way depending on the exact altitude. With this study also confirming that overall, Uranus has been actually cooling down since 1990s, with the average temperature now being approximately 150 Celsius or 426 Kelvin. In other words, it seems to have dropped in temperatures in the last 30 years. This is probably the result of the seasonal changes, but also possibly some other activity we still don't understand. But interestingly here, the James Webb observations also discovered two bright auroral bands very close to the magnetic poles. But at the same time, it also discovered a dark region. This is where the emissions and density of particles seems to be extremely low. And in this case, this is believed to be caused by the planet's unusual magnetic field, which we know is tilted by approximately 59 degrees, and is also offset from the center of the planet. And so this lopsided field creates these magnetic silhouettes that then seem to dictate where the energy is distributed inside the atmosphere. And so, yeah, definitely not a boring planet at all, but a planet that seems to contain some of the strangest atmosphere and some of the strangest magnetic fields. But apart from Uranus itself, researchers also were able to take a look at 2 of its moons. And by the way, in just the last 2 years or so, researchers have actually found new moons around Uranus, which you can learn more about in one of the videos in the description. And so officially Uranus now has 29 moons. And it of course has these really massive rings. But most of the moons are really small, and it's really only these big 5 moons that are often the focus of the research. You can actually maybe see them a little bit better in this image. And so here's some of the recent research from 2025 provided us with very strong evidence that 2 of these moons, Ariel and Miranda, might be ocean worlds after all. And so for example, in this study that was published in early 2026, researchers modeled some of the tidal stresses on Ariel's surface, basically showing us how this moon seems to be stretched because of Uranus's gravity. These tidal effects are obviously pretty common in these systems, and on moons like Io in the Jupiter system basically result in massive volcanism. But for this moon they wanted to explain some of its very bizarre structures on the surface that resemble very massive ridges. Here's the actual picture taken by the Voyager probe back in the days. And so it turns out that the best way to explain these stretches is to actually have some kind of a subsurface ocean over 100 miles deep, or at least ocean that used to exist in the past. And so a lot of these Ariel's dramatic surface features, such as ancient craters mixed with a lot of young smooth plains, were probably shaped by the subsurface ocean that was possibly over 50% of the total mass inside the moon. Just as a comparison, this would be 40 times deeper than the Earth's Pacific Ocean. And well, here to explain this, researchers believe that anywhere from 1 to 2 billion years ago, Ariel was probably in some kind of an orbital resonance with its neighbor Miranda. And over time this interaction made Ariel's orbit a lot more eccentric, which created intense tidal friction, generating enough heat inside to melt a lot of ice and to form these oceans. And because of this ocean, this also very likely resulted in a lot of different activity on the surface, actually explaining why there is carbon dioxide ice and even ammonia ice that have been discovered on the surface in the past. And because these chemical compounds break down pretty quickly, it means that something from inside is replenishing them. So basically here there's a lot of cryovolcanism. But what's unclear is if this ocean still exists. And so without an actual mission to Ariel, we're unlikely to know anytime soon. But then we had a separate study on the neighbor Miranda, one of the strangest looking moons out there. And this moon is basically a kind of a geological mass. It almost looks like it was stitched together from completely different worlds, resembling some kind of a Frankenstein monster. But these new computer simulations suggest that 100 to 500 million years ago, Miranda also probably had a very deep ocean, maybe about 60 miles deep, so a little bit smaller than Ariel, but still much larger than the Pacific Ocean on Earth. But the thing is, because Miranda is actually a pretty small moon, finding evidence of an ocean here is a little bit surprising. As a matter of fact, there's even signs that it might still exist inside, at least as some kind of a thin layer of liquid that has not been completely frozen yet. But the evidence for this ocean is once again because of these tidal features that, according to computer simulations from this recent study, could only be formed if the moon had a very strange orbit and received a lot of tidal heating both from Ariel and from Uranus. But the main reason researchers believe the ocean might still be there is because the simulations also show that if the ocean has solidified and became ice, the expansion of ice would have created very specific types of surface cracks that are currently not seen anywhere on the surface, suggesting that the interior is maybe still cooling down and could still contain something liquid inside. And so both of these discoveries suggest that both Miranda and Ariel are kind of like these twin ocean worlds, very similar to moons like Enceladus and Europa, and of course a lot of other objects that we think contain water inside. And naturally, because we're talking about liquid water, there's now also a possibility of maybe life, which of course strengthens the case for a dedicated mission to Uranus even more. Now right now the only mission that's still kind of considered is this one, referred to as the Uranus Orbiter and Probe, but unfortunately as of 2026, it's been postponed to at least mid-2030s, and even if it's launched in 2030s, it's not going to arrive to Uranus until 2044. Yeah, that's like, what, 20 years from now almost. So don't expect any answers about anything anytime soon. And last but not least, I also wanted to briefly discuss what these planets even are. Because even though we call them ice giants, technically they're not made out of these ice cubes, similar to what you find in your freezer. And that's because deep inside both Uranus and Neptune, we seem to find something referred to as super-ionic water. And that's of course under millions and millions of atmospheres of pressure. And so here, by using several experiments using high-powered lasers, researchers also realized that the state of water is a lot more complex than we ever thought. And in this state, oxygen atoms sort of become a solid crystal, but hydrogen atoms start to move freely and start to act like a liquid, which actually allows this material to conduct electricity extremely well, which is why this object and Neptune both have very strong magnetic fields, but also magnetic fields that are somewhat lopsided. And that's because this is not really just about the structure, it's also about the mix of different patterns that inside these planets create structural irregularities and a lot of unusual, bizarre formations. Now this is something that we're still learning about and something we're trying to understand, but in essence, these objects are definitely not boring and seem to contain some really strange properties inside. And because these planets also represent some of the most common planets in the galaxy, studying them is important for a lot of other reasons. Because understanding these planets means that we understand a lot of planets out there. And so based on these recent discoveries, we can now pretty certainly state that Uranus is not just some kind of a quiet, frozen ball, but seems to be a very dynamic world with the atmosphere that's cooling down, magnetic field that's constantly changing, and at least 2 moons that possibly contain liquid oceans. And so studying Uranus teaches us more about exoplanets, but may also teach us more about the possibility of extraterrestrial life somewhere out there. Which means that we'll come back and discuss Uranus and Neptune in some of the future videos, once there's some additional updates. Until then, check out previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.